So, as you know, last week in America, it was a holiday, which means I didn't have a whole lot of time to work on things. Plus, I'm still waiting for enough parts to get a project together that I can start filming. So I thought I would toss something up in the meantime. This is just a project that I've been working on for my own personal gratification. I'm going to be running some tests on a microphone or a series of microphones. So I thought I would just walk you through a quick design process of how I toss something like this together, and that's using direct solid modeling to make a quickie prototype of something that is actually pretty good. So what we have here is a Shure SM7B broadcast mic, and I'm going to be reproducing the grill on it. And on top of that goes this windscreen. But I want to stick this onto an SM57 mic and see what kind of a difference that grill might make in terms of like internal resonance and sound diffraction, things like that. So getting some general measurements together, overall it's about 95 millimeters, at least what we can see. There's probably another 5 in there. The microphone sticks about halfway through that, and then the aperture of the holes plus the little supporting metal around it is about 4.75 millimeters squared. And we have basically a sliced conic section here, so a frustrum or whatever it's called. So it starts out at 52 millimeters on the base and narrows down to about 42 millimeters. And I'll be knocking this up in my favorite quickie program, which is still 123D, which is an old freeware direct solid modeling program that Autodesk put out before they phased it out in favor of Fusion 360, which is great, but it's not nearly as quick for, knocking out prototypes and changing it on the fly as a direct solid modeling program, so that makes me very sad. But I still have it, it still works, so I'm going to use it. So first thing I'm going to do is make our blocks and then use the hollow tool to hollow it out to about, a half millimeter shell, which is going to be 1 millimeter between the apertures. And then I'm just going to duplicate that a whole bunch of times in a row. It looks like from the picture, there's about 20 apertures. So I'm going to take this and multiply it, 20 times. And I'll be showing a lot of these parts in fast forward because they're excruciatingly boring and I wouldn't want to subject you to that. After I have my row here, I'm just going to go ahead and merge all of these together into one solid. And then I'm just going to slice that down to the angle that we need. Now, you could math this out and say, okay, well, our base is 42, or our base is 52, and our top is 42. So obviously, we're just going to form a right triangle here, and then take this space and math it out so that we can find the angle of this one side. But we know that 52 minus 42 is 10, divide that by 2 is 5, so I'm just going to go 5 and then slice it up at the top, draw a line with just the polyline tool, and use the plane cut to just slice that. I'm going to rotate this 90 degrees and pop it up onto the plane, and then use the multiply tool to follow the axis of this circle that I drew, and then we're just going to turn that into a cylinder, merge all of the pieces together, and again, make that just one solid part. And this is what I came up with. So from that, I'm going to put this little base down at the bottom, and I'm going to make that clear so we can see through it. Try doing that quickly in Fusion 360. And bump this up just to slice the bottom off because I want to make this a solid part so I can put some screw holes in it. And we're just going to subtract the one solid from the other solid. And then I'm going to go ahead, flip it up, select the bottom edge, and then use the extrude tool to just pull that down. Now I have to take this bottom part and make it solid. So I'm just going to draw a cylinder and merge those two together. So you can see how they overlap ever so slightly. And then again, we're just going to additively select them and make them one solid object. After that, we're going to take our microphone analog, which is just this piece up here. This is the same diameter as the microphone that's going to be slipping over. Push that down to the bottom. I'm going to make a copy for myself just in case I need it in the future. And then subtract that from the solid to make the mounting hole. Now I want to mount these with 3mm set screws. So I just drop this cube in here, and then I'm going to snap a bunch of these 1mm cylinders to the edge of it and subtract those from the solid. That way we have our 4 little screw holes right here, and then delete the cube. And now for the really tedious part, making the top grill. This is super fast forward because this is really dumb. I just have to multiply these a whole bunch of time and then subtract them from the solid to make our mesh. So after we have that, just pop it right up here to the top. Again, merge it, and then probably use a plane slice tool just to make the top smooth. And then I'm just going to add a little chamfer around, or bevel or whatever, around the bottom here on each of these, just to give it a little bit more of a support, because I'm going to be 3D printing this, I think. And, it's like 2mm thick down there, so I want to make sure that it's, a decent base. And then I'm going to add a little bevel to the edges of each of these screw holes as well, because the printer's going to be moving at 90 degrees on a lot of those, so it might add a little bit of ringing. So if I smooth that out, then it'll print easier and I'll have to do less post-processing work to get that to be an accurate hole. So right here, I'm just annoyed that the edge has kind of flat spots on it. I want it to be nice and smooth. So I'm just going to take this big cylinder right here, measure it out properly, and then subtract one cylinder from the other, and then subtract that from the outside perimeter of our model. That way it'll give it a nice smooth edge and it'll, just look a little bit better. Then we're going to do a couple other things. So I'm going to export it as an STL and just take a look at it. For you non-Mac users, I bet you didn't know that if you hit the spacebar in an STL, it'll come up in physics engine and everything. Actually, let's do something even stupider since we're doing dumb Mac tricks right now. Open that up in Xcode, and then we have our 3D model right here, and we can add a whole bunch of lights. So we'll add a directional light there. Yay, dynamic lighting, but that's not terribly exciting. Let's do a spotlight. Ooh, cheesy Xcode tricks. Oh, let's be even dumber. Let's put a sky behind it. Yeah, procedurally generated sky. Or we can be more practical and just use a gray background. So now we can do those, fake product renders that you see on the web all the time. Anyway, cheesy dynamic lighting effects. There you go. Back to practical land. So I'm going to dump this into Mesh Mixer, and I'm going to make sure that it's thick enough. So I'm going to use the thickness tool to see if anything is under 1 millimeter, and a lot of it is. So I'll go ahead and select that, and then go to edit and then extrude, and oops, that's our wrong extrude. So that's constant extrude. We want to go around here to the direction and use normal, and then that's going to thicken it up, as you can see, and we'll just make sure that all of that is at least 1 millimeter so it prints right. Now you can go back to quick look and compare our couple different thicknesses that I printed out, just in case I have some kind of printing problems. Now, I thought I would be fancy and go to one of these 3D print for you type places and get this SLS printed, but they wanted $30 freaking for it, and you can buy the actual real deal metal one for like $42, so screw that. Because right now I have volcano nozzles on all my machines because I'm printing out like prototype parts for a new machine design that I'm doing, and I don't feel like swapping them just for this and swapping them back again. So it would be a real pain in the butt to try to print all that stuff with a volcano nozzle, even if it's possible with the diameters as small as they are. So this will have to wait, but I figured I would put this video out so you'd have some content in the meantime, and maybe you would get something for it. So hopefully I get some parts in soon. I can do something more technical, but until then, get out there and make something awesome.